expression. One thing that's important to note that in order to do this, you do have to be using the same base for your log. So notice these are both log base 2, so I can go ahead and do this. We're going to use those same properties of logarithms we used to expand the expression, only this time now we're going to condense it as much as we possibly can. So remember that. We'll just briefly go over this. That our properties of logs that we used is that when you have two logs that are the same base and use addition, you can rewrite them as a single log with multiplication. If you have two logs with the same base that are subtracted from one another, you can rewrite them in a single log as division. And anytime you have a number in front of your logarithmic expression, you can bring it up and make it into an exponent for that value. So that's what we're going to look for. The first step we'll do is any numbers in front, we're going to bring those up and write them as exponents. And then we will bring the logs together. So notice we have a 3 here in front of the log base 2 of x. So our rules of exponents tell us that our job is to write that as an exponent for our x over here. So we have log base 2 of x to the third power plus log base 2 of y. Now our rules for exponents tell us, or excuse me, for logarithms tell us that we have two logs with the same base like we do here, and they are added. We can rewrite that as a single log with the base of 2 in this case, because that's what we had. And addition means those variables would be multiplied when we write it as a single log. So we are done. Log base 2 of x to the third times y would be the same as this expression, only it's written as a single log instead. Okay, let's do a few more examples. All right, we have 1/2 log base 3 of x. Again, note that they're all log base 3 so that we can actually make this workable. Our first job is to take any numbers in front and bring them up as exponents for those variables. So we have log base 3 of x to the 1/2 power plus log base 3 of y to the 4th power minus log base 3 of z to the 2nd power. Okay. Now another thing I want to note is that the 1/2 power is the same as writing the square root. So I'm going to write it that way instead because that's the way we're accustomed to seeing it. So we have log base 3 of the square root of x plus log base 3 of y to the 4th minus log base 3 of z squared. Now as we look at our signs, anything that's addition will become multiplication when we write it as a single log. Anything that's subtracted is going to be division, so will be in the bottom of a fraction. So the z squared is subtracted. That will be in our bottom of our fraction. The square root of x is, notice there's positive in front here, and the y to the 4th positive in front of that. So those will both be in the top with multiplication. So we have log base 3 of the square root of x times y to the 4th all over z squared. And that is our single logarithm. Right, next example. Again, our first job here when we're asked to write them as a single logarithm is to take any numbers that are in front and bring those up as exponents. Okay, so I have a 3 in front of the ln of x, so I'm going to bring that up and I'll have ln of x to the 3rd power minus a 1/2 here. Remember that I'm just going to shorten this to a single step here. The 1/2 power is the same as the square root. So we have the square root of y minus, again here with our z, we have the 1/2 power, which is the square root of z. Okay, now let's combine those. Anything with positive in front will be in the top of the fraction as multiplication. anything with a negative in front will be in the bottom as division. So we have the natural log of x to the third was positive, minus ln square root y, so that will be divided, and the square root of z was also subtraction, so it will also be divided. I can do one more step to make this a little more simplified. Since the square root of y and square root of z, they're both square roots, I can combine those. So some of the rules that go with square roots, you can go ahead and do that. So I have the natural log of x to the third over the square root of y times z. And one last example. We have negative 1/4 of the natural log of a minus 1/4 the natural log of b plus 1/4 the natural log of c. Again, notice these are all natural logs. They have the same base, so it is legal for me to combine them as a single log. First thing we're going to do is take our exponents up. So I have 1/4 here. Remember, 1/4 means fourth root. Okay, so I'm going to go ahead and just write it that way. So the natural log of the fourth root of a minus, b has the same situation, the natural log of the fourth root of b plus the natural log of the fourth root of c. Now that we've taken care of those numbers that were down in front, we want to rewrite this as a single natural log, or ln, with using addition and division and multiplication. Now, like we said before, anything with a negative sign in front, so the a and the b, that indicates division, so they will be in the bottom of the fraction when we put these together. Anything with positive, or c, indicates multiplication, so it's going to be in the top. All right, let's go ahead and write that down. So we have the natural log, the fourth root of c was the only thing that was multiplication, and in the bottom we have the fourth root of a and the fourth root of b. Again, I can do one more step to simplify that. Notice they're all the fourth root, so I can write them together, everything under a fourth root. So I have the natural log of the fourth